figure out what.
Okay, so the technique when completing the square is to take half of the coefficient of the x term and square it,
Mhm.
and then add it inside the parentheses. Now, because I added 4 to the left side of the equation, what do I have to do to the right side of the equation to maintain
Add
balance?
4.
Now, because I completed the square, every time you complete the square, you will be able to write the new product as a linear term squared. And in this case, it's x plus whatever you got when you took half of 4. Well, you got 2, right?
Yeah.
So this term can be written like that, only it's now equal to 17. Now, how do you solve this?
You take the square root,
Okay, so what do you get on the left side?
x plus 2,
And what do you get on the right side?
the square root of 17,
Actually, whenever you solve an equation by taking the square root of both sides, you
plus minus.
100% of the time start your answer with those two things.
Okay,
So
plus minus
it's
square root of 17.
plus or minus the square root of 17. So what's x equal to?
X is equal to 2, wait, negative 2 plus minus the square root of 17.
Notice how similar that looks to the quadratic formula answers that you get. And if I would have used the quadratic formula to solve this in the first place, this is exactly the answer I would have gotten. So you can decide for yourself whether it was easier to complete the square to solve this, or whether it was easier to use the quadratic formula. So it gets a little more complicated as the degree of the problem gets bigger.
Yeah.
So let's try the following problem and change that to a 3. And we'll make this 5. So very similar problem. And you'll notice the biggest difference is I've left the constant on the right side of the equation. Whereas normally you would bring the 5 over and you would make it like this. This is the way you would typically solve a quadratic, is you'd put everything on one side,
But
0
isn't for
on the
completing the
other.
square, you have to put it into ax plus b equals c? Or no, b squared plus ax equals c. Isn't that the
Okay,
form?
I'm not sure what you're saying. That's not the quadratic formula. The quadratic formula is,
X equals negative b plus minus the square root of b squared minus 4ac over 2a.
so that's always going to be able to solve the problem.
But I'm saying for there are certain problems, like on tests, where the teacher will be like, you have to solve this in
Yes,
completing the
if
squares.
they
And for completing the
insist,
square, wouldn't you have to move the 5 over to the right side?
yes. And then A would be 1, B would be 3, and C would be minus 5. And if we do that real quick, we get minus 3 plus or minus 9 minus 4 times 1 times minus 5 all over 2. So this gives us 9 plus 20. So I can make that 29. You see what I'm doing?
Uh-huh.
So we make that 29. And that's your answer for this quadratic. So that's doing it using the quadratic formula. But you said let's work with completing the square. So let's solve this by completing the square instead of using the quadratic formula. So when you're completing the square, you don't move the 5 to the other side. You leave it over there. And what you do is you complete the square inside the parentheses. So what's the formula again? What's the method? What am I going to do?
You're gonna take half of the coefficient, which in this case would be 1.5
Okay,
or
let's
one.
keep everything in fractions and not use
Okay.
decimals. So half of 3 is 3 halves. And now square it. Square 3 halves.
Um, wait, oh,
Square the
goodness,
numerator, square the denominator.
9/4.
So we're going to add 9/4 there. And that's going to guarantee us that I will be able to write that as a linear term squared. But the most important thing to keep in mind is I can't just add 9/4 to the left side of this equation without balancing it by adding 9/4 to the right side. Now, I haven't changed anything. So all I did was I took the original problem and I added 9/4 to the left and 9/4 to the right. And because I was completing the square, I can now write this as what? X what?
X plus 3x.
It's always what you got when you divided that by 2.
Oh, x plus 9/4 in this case, or 3/2.
No, it's not what you got
Uh,
when you squared it. It's what you got when you divided it in half. 3 halves.
okay,
If you do that procedure, you will get this. I promise you.
all right.
That's
And then
the whole
that'll be,
point.
it'll
That's
be
the
equal
whole
to,
point of completing the square, is that I will be able to write this thing as this is a linear term squared. And then it's going to make solving it much easier because I'm going to be able to solve it by taking the square root of both sides. So first of all, let's add those two together. What do you get?
you get, sorry, your thing is in the way
Find
right
the
now.
least common denominator.
Yep, yep. Um, 5 plus 9/4 is gonna be, oh my goodness, why am I blanking? This is embarrassing.
How many fourths is 5?
20/4.
Okay, 20 plus 9.
29/4.
Okay. Now, keep going. Now, how do you solve it?
Then you would take the square root.
Okay, what's the next line going to be?
X plus 3/2 equals plus minus 29/4.
Equals plus minus the square root.
Square root of 29/4.
So your answer is what? X equals,
X equals -3/2 plus minus the square root of 29/4. Okay, that makes so much sense.
and notice that's actually not the final answer
Oh,
because you always want to simplify it if you can. I can take out, in other words, over here on the lower left, the square root of 29/4 is the same thing as the square root of 29 over the square root of 4. And this is 2. So I can replace that and call it 2. So now this lower answer over here where I'm pointing, I'm going to write that as the square root of 29 over the number 2. So that is the answer, which totally agrees perfectly with what we got when we used the quadratic formula. You will always get the same answer, just used a different technique.
Okay, that makes sense.
Okay, it gets harder.
Oh, shucks.
Oh, that's okay. As long as you use the right methodology, you will always be okay. And this is not the only use of completing the square. There's lots of uses for it. When you get to conic sections, you'll have a use for it. So I'm going to change this a little bit to this. So the first step in completing the square is usually to add parentheses, and you add them and you leave enough room to add something because you know you need to add something there, right?
Yeah.
Okay. You cannot complete the square if this coefficient is not 1. Has to be 1. So I have to factor out that 2.
So divide everything by two.
Okay, when I do that, I get this. And the key here is never change it. When I'm going from this row to this row, they are the same. And a good habit with math is to multiply this back together again. And, oops, excuse me, there's no 2 there yet. Multiply this back together again to make sure you get what you started with. And sure enough, I get 2x squared plus 6x. Okay, you with me?
Yeah.
Okay, now because the coefficient of the x squared term is 1, it's not 2, it's 1, because I'm only dealing with what's inside the parentheses. So now I complete the square in a normal manner. So what am I going to add here again?
You're gonna add half of the coefficient
Squared.
squared.
So tell me what that number is.
Um,
Don't work in decimals
nine
ever.
fourths.
9/4. Okay, so now I just changed the left side of the equation. How much did I add to the left side of the equation?
Um, a lot. I mean, nothing actually.
Oh,
Nothing.
no, it's very concrete. What is it?
Nine fourths.
No, it's not 9/4. It's 2 times 9/4.
Oh.
So what is that?
2 times 9 fourths.
Mm-hmm.
18 eighths.
Oh, it's 18/4.
Oh,
Okay. So that's what I have to balance. I have to add 18/4 over here to balance. And now this row is identical to that row. I have not changed anything. That's what you don't ever want to change it. I can't just arbitrarily add a number to one side of this equation without adding it to both sides. If
uh,
you multiply this out, and add those two, you would get this first row. Okay. So now where do we go from here? Well, we can add this again. That's 20/4. So we have 38/4. And over here we have this. So now let's get rid of that 2. What are we going to do with that 2?
we're gonna divide it. Divide
Okay.
everything.
So I can cross that
Okay,
out.
crossing out there and then dividing that side by two.
Okay, you with me?
Yes.
I divided both sides by 2. And this now actually becomes, I can divide both sides by 4. Excuse me, I can divide both sides by 2. So it becomes 19/4. is now on the right side of the equation. Stop me if you don't understand what I'm doing.
I will.
What am I going to write here to represent this quadratic up here? It's going to be a linear term squared.
Linear term squared would.
Linear term means it has an x to the 1, not an x squared. This is a quadratic term. This is a linear term. It always
X
uses this
plus
sign, always. If that's a minus, then it's going to be a minus. In this case, it's a plus. What goes here?
3x. No.
What'd you get when you divided that by 2?
Oh, oh. 3/2.
That was 68. No,
Wait.
that was 38 over 4, 19 over 2. I made a math error. So that's 19 over 2. Now let's get rid of that 4. That's what it was. When I added those two together, I got 38 over 4, which is 19 over 2. So now I have that. What's the next step?
Um, the next step is taking the square root.
Okay, tell me the next line.
X plus 3/2 equals plus minus the square root of 19/2.
And so let's erase all of this and this. So what's our final answer?
Our final answer is X equals negative 3/2 plus minus the square root of 19/2.
This time, this thing cannot be simplified. It doesn't do any good to call it the square root of 19 over the square root of 2. That makes it actually more complicated. When you're simplifying radicals, you only simplify them if you can pull a whole number out. So if that was 19 over 4, I'd be able to pull a 1/2 out. But because it's 19 over 2, I can't. And that's the final answer. And that's about as tough. Now, let me do one more, just so you'll understand. So we have this. Again, I could move the 7 to the left, and I could use the quadratic formula. But if you're trying to learn how to complete the square, this is as tough as they get. So what's the first thing I have to do?
Um, add half of the
No,
coefficient.
no, no. You cannot complete the square until that's a 1.
Oh, yes, 2, like outside of the like parentheses, x squared plus 5/2x.
And notice that 5 is not divisible by 2, but that doesn't matter. You still have to factor out the 2. And I'm going to leave some room to complete the square, so I don't put my parentheses there. I put them over here. Still equal to 7. Nothing's changed. It's the same as the first row. Now complete the square. And when you complete the square, you are always adding, even if that's a minus sign. Because when you square a negative number, it becomes positive. So it doesn't really matter whether that's a plus or a minus. You're going to square 5/2.
Okay. So
Just square the top and bottom. That's the easiest way to do it. And
25/4.
that's why you want to leave it as an improper fraction, not a proper fraction. If I converted that to 2.5, not so easy to square 2.5. Very
No.
easy to square 5/2.
Yep, 25/4.
Okay. So what do I have to add to the right side to balance? Because I just added a number to the left side, and you can't do that without balancing.
You have to add 25/4.
No, I have to add whatever I added to the left side of the equation when I wrote
25,
25/4. It
14.
was not 25/4. It was 2 times 25/4.
50, 20, whoa, 58ths.
50/4.
Fourths.
2 times 25/4.
There's a little like line to the left of the four. And I know when I look back at this, I'm gonna try to figure out if that was like 14 or something. Could we erase that? Yeah. All right, thank you.
So now everything is balanced. So let's add those two.
Um, 7, 4. My goodness gracious.
What
Yep,
is
yep, yep.
7 when expressed in,
28.
okay, so we have 28/4 plus 50/4. We have 78/4. This 2 is still there for the moment. And now let's write the linear term squared that we're going to get. And you're guaranteed to get a linear term. That's what the whole process of completing the square guarantees you, is that I will be able to write this as a linear term squared. A linear term means x, it's plus because of that plus right there. And what goes here?
Um, 25/4.
No, it's whatever you got.
Oh, 5.
Hold on a second, just a second. Yeah, we made a mistake. Let's go back and correct it. So here, let me get rid of everything. So we're at this stage here where it agrees perfectly with what we started with. So how do we complete the square? We take half of that and square it. We don't take that and square it. We take half of that and square it. So what's half of 5/2? We got the 2 there, not because we divided it by 2, but because we factored out a 2. So ignore this 2. That has nothing to do with completing the square. And complete the square inside the parentheses. Take half of the coefficient and square it. What's half of the coefficient?
5 over, no, oh, shoot. Um, half of 5/2.
Uh-huh.
Um,
What's that?
um, wait.
Multiply numerators, multiply denominators.
It's
What's 1 times 5?
5/4.
Yeah, that's 5/4. So that's what you get when you take half of 5/2. Now square that.
Um, 25/16.
And now balance.
50, 30 seconds.
Oh, when you multiply 2 times this
Oh, 50
fraction,
sixteenths.
yeah, you only multiply the numerator by 2. You don't multiply both of them by 2. So when we wrote in 25/16, we added 50/16 to the left side of the equation. So we have to add it to the right side of the equation. Now, these are not coming out to be pretty numbers. They weren't meant to be. I picked them out of thin air. But this is what you get when you complete the squares. You get odd fractions. So next step, what's that? In a improper fraction,
Um, ah,
1/12 is what 7 times 16 is.
one,
Yeah.
wait, 112?
1/12 over 16 is the same as 7.
Oh, 162 over 16.
Okay. So 162 over 16. And on the left side, I still have that 2. And how can I write what's inside the parentheses?
Um, is it still 5/2? Wait,
What you got when you took half of that before you squared it.
5/4.
Now, let's get rid of that 2 by dividing both sides by 2.
Yep. So
So if I divide the
5
right
both sides by
side
2,
by
you
2, I
get,
can just make that 81. And
okay,
you
so x in parentheses, x plus 5/4 squared equals 81 divided by 16, and then take the square root of both.
okay, I'm gonna make some room here at the top so we can do this. So x plus 5/4
Equals,
equals plus or minus the square root of 81 over 16.
which is also 9/4. So,
Yes, very good.
and then
So
x equals 4 over plus minus 4/4, so x equals plus minus 1.
always put that number first.
Oh,
Minus
but
five
yes,
fourths
minus 5/4,
plus or minus 9/4.
and then you kind of just solve it, right?
Well,
We just
yeah,
solve it
it
out.
happens, it just so happens that
But this one is solvable.
accidentally the number I pulled out of thin air gives you a very nice solution. So what are the two solutions? Let's make sure you understand that,
Negative 5/4 plus 9/4.
which
So
is,
1, 4/4, 1.
and what's the other solution?
Or negative 5/4 minus 9/4, which is negative 14/4. Or that could be 7/2.
Yeah, you definitely always want to take it down. In other words, you wouldn't want to put an answer of 14 over 4. Teacher's going to deduct a point for that
Yeah.
if you don't simplify your improper fractions. So there's the two answers to this fairly complicated quadratic. And I think I have gone through all of the difficult ones.
But
Ones
this
where you
actually
have,
makes so much sense. Like, thank you so much. This really helped.
sure. And yeah, you could have gotten by using the quadratic formula on all of these. But when you get to conic sections, there's not that option. You won't have the option of using the quadratic formula, and you'll have to know how to complete the square. So you want to know how to complete the square regardless of whether you're using it all the time or not.
Uh-huh.
All right, we stopping at 8?
Yes.
Okay,
So sorry, I've got the homework to do.
it's all right. I understand. Okay, sounds good. I don't want to schedule you for an hour if it's going to be a half hour. Thursday night is really a busy night for me. I
It's
can't
probably gonna be
afford.
an hour at other times. This time I just got home from school later.
I'm fine with that. I'll schedule you for an hour for next week.
But if next time, if it doesn't be 30 minutes, I'll let you know earlier.
Okay, sounds good.
All
Yeah,
right.
thank you. Talk to you
Thank
next time.
you.
Bye
All
bye.
right.